Okay, so we're going to go ahead and take a look at some guided notes here. They're over reflections, and we'll just start with some basic definitions. A reflection is a transformation, is your first blank right there. Pretty sure I left out an R, but you can fill it in better when you get your copy. A reflection is a transformation in which a geometric figure is, no surprise here, reflected across a line, creating a mirror image. That line is called the axis or line of reflection. I think either one of those would be acceptable. You can do the reflection by visually transforming the points, or you can use a formula. If you are reflecting over the x-axis, then you can use this formula. F of x comma y transforms to x negative y. So basically, you are going to flip the y component. For example, if I started with, say, 2 and 3, then that would transform to 2 comma negative 3. That's if you're flipping over the x-axis. If you're flipping over the x-axis, then you switch the y-coordinate. It's backwards, but that's the way it works. On the other hand, if you're reflecting over the y-axis, then you can use this formula. F parentheses x comma y transforms to negative xy. That basically means that you're going to flip the x component. For example, if you started with 2 comma 3, then that would transform to negative 2 comma positive 3. Once again, opposite of what you would think. If you're flipping over the x, you flip over the y. If you are reflecting over the line, y equals x, then you can use this formula, f of x, and basically you're going to switch x and y positions. For example, if I started with 2 comma 3, then that would transform to 3 comma 2. And here's a bonus formula that I added in here that you'll need for the IXL. If you're flipping over the line y equals negative x, then you flip the x and the y and you switch their places. So for example, if you did f of 2 comma 3, that would transform to negative 3, negative 2. Okay? Let's actually work out a couple of these examples and actually see how it works. So let's get nice and centered right over this first example. Bring the camera down so you can see it nice and clear, or as clear as possible. First, we want to find the preimage points. So we will find coordinates of h, which is negative 4 comma 10. Go ahead and write that down. Find coordinates of e, that is negative 4 comma 9. Then we'll find coordinates of f, or g. We'll do 0 comma 10. And coordinates of f are 0 comma 9. Okay, we can either visually plot the points or we can use the formula. The formula is f of xy transforms to, and since we're flipping over the x-axis, then we're going to keep the, if we're flipping over the x-axis, oh my goodness, I just realized I screwed up on the picture here, but we'll have to live with it. If you're flipping over the x-axis, then you're going to keep the x-coordinate the same, and you're going to flip the y-coordinate. So the x stays the same, so h prime stays at negative 4, and then the y-coordinate needs to flip from a positive 10 to a negative 10. Same thing on this one. You're going to keep the negative 4, and you're going to flip the positive 9 to a negative 9. Keep 0 and flip this 10 to a negative 10. Keep the 0 and flip this to a negative 9. Okay, I've totally messed this up, but you're just going to have to live with it. I'm probably going to plot the points on this one. It would be at negative 4 here, and then you would have to count down 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then negative 4, comma, negative 9. So negative 4, negative 9 would be right there. And then negative 4, 0 to negative 10, and 0 to 9. So here's my line of reflection, and I'm missing all this graph in here. So this reflects across this line to produce this shape right here. Hopefully I did a better job of getting the graph right on the next one. But at least I've got the image points correct. Okay, let's look at the if you're reflecting over something other than an axis, it gets a little trickier. Now in this case, help me with these, help me derive them. But here's your two formulas. Say your line of reflection was x equals 4, then your A would equal 4, and you would use this formula. You could just take and plug in 2 times 4, that's 8. So your transformation would be 8 minus x, comma, y. And then say right here, if your y equaled 4, it would be the same thing, just switch them around. Your A equals 4, so you'd switch it around. You leave your x, and then you do 2 times your A value, which is 4. So that'd be 8 minus y. Tricky, and it doesn't immediately make sense to you, but that's the way it works. So let's actually apply that formula on the back here. Okay, let's see if I got this right. So what formula should we use? We are reflecting across the line y equals negative 1. So we should use the second formula. X is going to stay the same and we'll transform the y. So the formula we should use is x stays the same and y transforms to 2a minus y. Okay, where y equals negative 1. So if I plug that in, I'm just going to use some blank space here. Actually, I'll write it up here. You're going to do x, comma, and then y is negative 1, or yeah, that's y is negative 1, so a equals negative 1. So we plug that in, 2 parentheses negative 1 minus y, which simplifies down to x, comma, negative 2 minus y. Okay, now check this out. I'm going to apply this transformation to each of the preimage points. So let's do that. First, preimage points, that's easy, just list them out. That's 2, 6. That m is going to be 4, 8. The n is going to be 4, 3. The k is going to be 2, 1. Now we apply the transformations. So let's do calculations for L first. L, we use our function f of x, y is x, negative 2 minus y. So L is 2, 6. So we're going to do f of 2, 6 transforms to 2 parentheses or comma negative 2 minus, what is our y value? 6. And that becomes 2, and we're going to do negative 2 minus 6 is a negative 8. So our transformed coordinate for L is going to be 2, negative 8. Okay, let's do it for M. So I think I have enough room maybe to get some of M on here. Our M point is equal to 4, 8. So I'm going to chop off the first half here and just focus mostly on the second part. Our x stays the same, so we can leave that 4 in there. And then we're going to do negative 2, because that's part of the formula, minus, and then y is 8. So we're going to do m transforms to 4, negative 10. So we're going to go ahead and do a 4, negative 10 here. Okay, all these should be primes. That'll probably be fixed on your copy. Okay. Alright, so we've got 2 points, but we still need 2 more. At this point, let's just go ahead and draw our line of reflection at y equals -1. So I'm drawing my line of reflection here. And I'm going to plot my first 2 points. So 2 and -8. And also 4 and -10. So you see how this right here is going to reflect this line up here. You can barely see that line of reflection on this camera. Hopefully that helps. Right there, if you can see that. Okay, now let's do endpoint. Another way to do this is visually. Instead of having to do all this math, you can just count. If you draw your line of reflection on here, you can just count how far it is. This should be the midpoint. So if it's 2 units this way, then all you have to do to reflect it is come back 2 units this way. So let's just count. 1, 2. So that would go there. And then if we count, this is 1, 2, 3, 4. And this would be 1, 2, 3, 4 units that way. And as you can see, we've got a perfect reflection across y equals -1. Okay? It's not that tricky, but you do have to pay attention to what you're doing. Let's just go ahead and fill in the rest of these points. That would be 4, -5. And the k value would be 2, -3. Oh, got that wrong. Good thing I have an eraser. 2, -3. Okay, so there you've got all your points there. And then on this bit right here, I would just like you guys to do the independent practice. You can list the image and preimage points if you want. You're not required to. But if you are asking for help, the first thing I'll ask you is if you've listed your preimage points. And then we can work from there. Hopefully that helps. Thank you guys.